Well, now that you've learned how to add fractions uh, and mixed numbers, it's only natural that we move into subtracting. And once again, I've written a note right here, just like we did on the adding one. Subtracting mixed numbers can be done by converting them proper, but it is just very inconvenient. Um, a lot of scratch work, and the more scratch work you have to do, the more mistakes you're likely to make. So we are not going to be doing it that way. I'm not saying the math is incorrect, but I had some students in the past that really sort of insisted upon doing it that way, and they really suffered. Um, they weren't consistent with it. So I am asking students this year not to do that and to do it using the mixed numbers instead. I showed this first one vertically, but I still think horizontally is the best way, and the rest of the notes I will show the problems horizontally. Subtraction, the only thing that's different is sometimes, not in this first case, but sometimes this fraction right here is not bigger than this one right here. In this case it is, so it's pretty simple. 9 minus 6 gives you 3, and 3/4 minus 1/4 is 2/4. 2/4 equals a half. Pretty straightforward problem right there. But you could have 9 and 1/4 minus 6 and 3/4. And that would lead us to this situation. The first fraction, if it's larger than the second, we have to rename, or some people call it borrowing. I sort of grew up in the borrowing generation, but now they've decided to call it renaming. I don't really care which one you call it. To rename a fraction, all you really have to understand is that you can rewrite a whole number as any number divided by itself. 2 over 2, 3 over 3, 12 over 12, 9 over 9, 100 over 100, 976 over 976, etc. That's really the skill. So let's take a look at a problem on page 2 here, and I've worked it horizontally as well and sort of just written some notes out to the side for it. So this one is that tougher type, so to speak. So when I refer to the tougher type, that means the first fractional part of the mixed number is smaller than the second fractional part. So made a little note right here. You're going to have to rename the first fraction because this 2 is greater than this 1. I can subtract 3 from 5, but I won't be able to subtract 2/3 from 1/3 without getting a negative. So instead, I change the 5, I borrow a whole from the 5. So the 5 becomes a 4. And the 1 that I borrowed is right here. So technically I've got 4 plus 1 disguised as 3 over 3. 4 and 3 over 3 represents the 5. And then I just left the 1/3 alone. Here's your 1/3. Well, 1/3 and 3/3 is 4/3. So now that you've rewritten 5 and 1/3 as 4 and 4/3, now you can actually do the subtraction the same way we were doing the addition before. 4 minus 3 gives us the 1, and 4/3 minus 2/3 gives us 2/3, and the problem is finished. So down here in the kind of salmon box, I said, well, what is really happening actually? Well, the whole that you borrowed is rewritten as 1 in fraction form using the same denominator as whatever your original fraction was. This little shortcut right here is really handy. I mean, I think it's important to know what's happening, but sometimes the mechanics of working through that every time you work a problem makes the problem a little more challenging. So I'll kind of explain in the next problem what we're doing with this shortcut, but I will use the shortcut in the rest of the notes. It says the numerator plus the denominator of the original fraction is your new numerator, and you keep the same denominator. Let's back up to the first one, and you can see it. And I'll turn on the little highlighter here. So if you add these numbers together, 1 and 3, you will get 4. So 4 is your new numerator. And I kept the same denominator, 3, that I had to start with. So the reason that works, of course, is because every time, whatever the denominator is, the one you borrow is that number over itself. So just a little shortcut that makes life easier. And with fractions, we need some things that make it easier so people won't be quite so freaked out about working them. All right, well, let's try it on this one. And again, I'll show my work horizontally. So step number 1 is always to get a common denominator if you don't already have one. So 4 and something minus 2 and something. 5 and 6, we'll have to use 30. So 5 goes into 30 6 times. 6 times 1 is 6. 6 goes into 30 5 times. 5 times 5 is 25. Again, if you're struggling with the renaming or rewriting it as 25 over 30 there, remember right here, it's really like we're multiplying the bottom by 5, so we have to multiply the top by 5. Needless to say, if you're going to be doing that on your problems, you're going to need to rewrite the original problem. You should never write on the original problem in your work. It's messy. When you go back to kind of check, you can't tell what your original problem was, so it's just a bad idea. So you get here and you realize, oh, this is one of those problems where I need to borrow. I need to borrow because 25 is bigger than 6. So instead of marking a lot of stuff out and all that, like we normally would when we borrow, it's really not necessary. Just subtract 1 from the 4 to give you a 3. And if you use the shortcut I gave you, your new fraction is 6 plus 30. You're adding these values together to give you 36, and you keep the denominator. That's exactly the rule I wrote in the salmon box above. This fraction is just being brought down exactly as is. You can check yourself if you're confused or not sure you're doing it correctly. You could think, well, 36 divided by 30, that's 1 and 6/30. Well, 1 and 6/30 plus 3 is 4 and 6/30, which is what you started with. So now I can subtract. 3 minus 2, 1. 36 minus 25. And in my notes, I'm just going to write that there, just so I can see it a little bit better, so I can subtract and easily see now that it's 11. So I have 1 and 11/30. Really pretty easy, and so much easier than multiplying. 4 times 5, 21, getting 21/5 minus 2 times 6, 12, 17/6, and then getting a common denominator with those big numerators. Much, much easier. All right, let's try it again over here with number 4. So still need a common denominator, but I've got 15 and 20. So if I need to kind of go over to the side, if I'm not able to see what it is, what you don't want to do is don't just multiply them together every time. They have factors in common, so their least common multiple is not 15 times 20. So we could come over to the side, maybe do a little ladder that we've learned to get the LCM. So we'd get 3 and 4 right there. Well, we're through with the ladder, so the LCM between 15 and 20 is 5 times 3 times 4. That's 12 times 5, which is one of our multiplication facts, so it's 60. So I've got 32, and blank 60ths minus 14 and some number of 60ths. Separate that. So we ask ourselves, well, what do you have to multiply by 15 to get 60? Well, just look over here at your LCM. It'll help you. There's 15. You have to multiply it by 4. 4 times 8, 32. What do you have to multiply by 20 to get 60? 3. 3 times the numerator. 3 times 3 is 9. In this case, you can see I don't need to borrow at all. 9 is smaller than 32, so just go ahead and subtract. So 32 minus 14 is 18. 32 minus 9. 32 minus 10 would be 22, so that would be 23. When you see a prime number as your numerator or denominator, don't assume that the fraction cannot be simplified. Sometimes the prime number will divide into the other number there. In this case, it doesn't, but again, just because 23 is prime doesn't mean we don't even consider simplifying. But this one is finished. Let's keep going. Now, I took a moment to just write out a common error, and I would really highlight that if I were you. It's such a common mistake. Oftentimes, when the first fraction is not bigger than the second one, students just subtract it in whatever order they want to. And so they'll subtract the first fraction from the second one. Please just be aware that that doesn't make any mathematical sense, so therefore, of course, it's illegal activity. Well, 11 and 8 have no common factors, so their LCM is their product, 88. So I'd rewrite 15 and something over 88. Ask yourself, what do you have to multiply by 11 to get 88? 8, so 8 times 9, 72. What do you have to multiply by 8 to get 88? 11. 11 times your numerator 7 is 77. So this is what I mean. A common mistake right here that you would not do is, this is what you would not do, is subtract the whole numbers in the right direction and then subtract 72 from 77 and say 5 over 88. Big no-no. So I'm going to leave that in my notes, and I'll actually work it the correct way underneath. Correct method. The correct method is, of course, to subtract 15 minus 6 and get 9. Oh, I'm sorry, is we're going to have to borrow. Yeah, well, we can't subtract our fractions. So we've got 15, so we're going to take 1 away. That'll give us 14. And remember, you take both of these numbers, you add them together, and that's your new numerator. So you've got 70 and 80, that's 150. 8 and 2 is 10, so that's 150 and 10, that's 160. Keep the denominator. I'm reviewing that way of adding with you so that you can just learn to just be a little bit more of a manipulator with numbers mentally. That'll really help you as you keep going forward in your math career. 14 minus 6, of course, is 8. Keep your denominator. And now we can actually subtract 160 minus 77. And that is 83. Yes, 83. I look at 83 and 88, and that 83 is prime. It can't be simplified, so I'm finished. So you're probably learning to appreciate that little shortcut right now when you're borrowing, because it really is helpful. Even when the numbers are kind of big like this, it's still easy to see. So definitely don't do the big no-no. Definitely do it the correct way. Now, number 6 is also a popularly missed problem. Students just like to say 4 minus 1 is 3 and then stick on the 8/13. But you're actually trying to subtract more than just 1 from 4. You're trying to subtract 1 and 8/13. So if we had to rename 4, I really can't use my little shortcut here, but I just use my brain. 4 would become 3 and 13/13 because that's like 3 and 1. Now, why did I use 13 over 13? Well, because that's what the denominator is for the second fraction. So you just subtract 3 minus 1, that's 2. 13 minus 8, that's 5. Keep the denominator. Can't be simplified, so it's done. Let's try number 7. First, if you just look at it, you might kind of want to just start trying to compare fractions mentally to get a little extra practice. Like 9 out of 16 is a little over half. 3 out of 12 is less than half. So I'm not going to have to rename anything in this problem. Now, 3/12, you can actually simplify that to start with. So if you ever notice that there's a fraction in the problem that can be simplified, it's always legal to just go ahead and do that. So I will rewrite 3/12 as 1/4. That will make finding my LCM for the denominators much easier. I know 4 goes into 16, so I'll keep my first fraction as is, and we'll rewrite 1/4 as 4/16. Now we're ready to subtract. You can see why no renaming. 9 minus 4 would be 5, so we'd get 6 and 5/16. Again, that cannot be simplified, so we're finished. Your work should just be really clear and easy to follow, and I didn't mention this, but your fraction bars need to be straight across, horizontal, no slant, okay? That causes a lot of problems in algebra, and I just want to break you of that habit right now. So just got a little quick review of the steps to follow. You rewrite the fractions using a common denominator. That's step 1. Determine if renaming or borrowing is needed. Remember, that is not going to happen on every problem. If it does, you take away one whole from the first whole number, and then this right here, this step, that's your little shortcut that I mentioned earlier, where you add the original numerator and denominator to create the new numerator. You subtract the whole number parts, you subtract the fractional parts, you simplify, and if the fraction part is improper, you have to convert and add it to the whole number part, just like we did on the adding. And then this is just a little encouragement for you. We can do it. This is olive oil. If you're not familiar with the old cartoon Popeye, the Sailor Man, you should check it out. This is his girlfriend, Olive Oyl, who is a force to be reckoned with. So go reckon with some fractions right now and be fierce. Good night, everybody.